Welcome to David Alexander Maths Tuition. This is Chapter 2C on composite functions. Okay, so here we've got two functions and we want to find, to start with, the fg of 2. So what we're doing is we're inputting 2 into g, and then whatever comes out of g, we're putting that into f. So we're putting this value here through the functions from the right going towards the left. So putting 2 through g, 2 squared is 4, 4 plus 2 is 6, and then this 6 is going through f. So that's going to be 3 times 6, which is 18, plus 5 is 23. For the gf of 0, I'm putting 0 into f, and then that answer into g. So the f of 0 is 3 times 0, which is 0, plus 5. And now I'm putting 5 into g. 5 squared is 25, plus 2, 27. For gg of 2, I'm putting 2 through this function. So 2 squared is 4, plus 2 is 6. And now I'm putting 6 through g again. 6 squared is 36, plus 2 is 38. So for the FGF of 1, I'm putting 1 through f, then what comes out of that I'm putting into g, and what comes out of g I'm then putting back into f again. So the f of 1 is 3 times 1, which is 3, plus 5, which is 8. 8 is now going into g. That's 8 squared, 64, 65, 66, and then this 66 is going back into f. So there's going to be 3 lots of 66 plus 5, which is 203. So just remember, you're working through the functions from the right to the left. So here we're trying to find an expression for a composite function. So we want the fg of x. So what that means is we're putting function g into function f. So in the function, so because we're putting g, this is g, and we're putting it into f, this x squared plus 5 replaces the letter x in the function f. So this x squared plus 5 will take the place of this x. So what we will get is 2 lots of x squared plus 5. Don't forget the plus 8. So all we've done is replace the x with the whole of g. And if we expand that out, we're going to get 2x squared plus 10 plus 8. So 2x squared plus 18. Here we're putting f into f. So in f, we've got 2x plus 8. And now this x is going to be replaced with the whole of a new f function. So it's 2 lots of 2x plus 8 plus 8. So if we expand that out, we're going to get 4x plus 16 plus 8, so 4x plus 24. Here we're putting the gf of x, we're putting the whole of the function f into g. Now g is x squared, so this x is being replaced by 2x plus 8. So it's the whole of 2x plus 8 squared plus 5. So we might want to expand out the 2x plus 8 squared to give us 4x squared plus 32x plus 64 plus the 5, so plus 69. Maybe it's acceptable just to leave it at 2x plus 8 squared plus 5, depends on the situation. And the gg of x, we're putting g into itself. So we are replacing this x with the whole of x squared plus 5. So it's going to be an x squared plus 5. That is squared plus 5. So all this x, as I say, the x here is being replaced with the whole thing. And that will give us, we might want to write 2 double brackets there for the x squared plus 5. So that's going to be x to the power of 4 plus 10x squared plus 25 plus 5, so plus 30. A little bit tricky, that last one, but just remember you're substituting the right-hand function into the left-hand function. Okay, so here we've got two functions, and a lot of the time we've just got all this kind of ugly looking stuff which seems very confusing. So x is a real number, but it can't be -3. The only reason they're saying that is because if it could be -3, then -3 plus 3 would be 0, and we can't divide by 0. Anyway, we want an expression for the gf of x, so we need to be putting f into g. So that's going to be 5 lots of 1 over x plus 3 plus 2. So that is 5 over x plus 3 plus 2. And 2, you could write that as 2 over 1 and do our crisscross smiley face here. So that's going to be 5 plus 2 lots of x plus 3, so 2x plus 6, all over x plus 3. So that becomes 2x plus 11 over x plus 3. There we go. So we've got it in the form requested, although c just happens to be 1. So for the next part, we want the gf of x, which you've just worked out. We want that to equal 5. So 2x plus 11 over x plus 3 equals 5, multiply through by x plus 3, so that will be 2x plus 11 equals 5x plus 15. Take away 2x from both sides, take away 15 from both sides, so 3x is negative 4, so therefore x is negative 4 thirds. Okay, so I think I might clear the screen so I can do this, got some space to do this last question. Okay, so let me just make a note that the function was 2x plus 11 over x plus 3. That was the gf of x. So we want to solve the gf of x equals the fg of x. So we need to work out the fg of x. So here I'm putting g into f. So where in f we have x, I'm replacing it with the whole of 5x plus 2. So the fg of x is going to be 1 over 5x plus 2 plus 3, so 5x plus 5. So we want to solve where these two functions equal each other. So what we have is 2x plus 11 over x plus 3 equals 1 over 5x plus 5. So I'm going to cross multiply, so therefore 2x plus 11 multiplied by 5x plus 5 equals x plus 3. So I'm going to get 10x squared plus 55x plus 10x plus 55 equals x plus 3. So that is 10x squared plus 65x. And I'm going to take away that x from the right hand side there, so plus 64x, take away 3 plus 52 equals 0. So I now have a quadratic equation that I can solve. So 10x squared, 64x plus 52. I mean, I could simplify the equation by dividing by 2, but I don't really see the point when I'm just chucking it into my calculator anyway. And I'm getting some pretty nasty solutions because I've not really thought very carefully about the question when I made it. So sorry about that. But x is negative 16 plus 3 root 14 over 5. And the second solution is probably the same, but with plus or minus 3 root 14 over 5. So there we go. Two solutions, both of which are fairly ugly surds in fractions, but there you go. Okay, so here we're trying to find the fg of 6. So 6 is going through g, and what comes out of g will then go into f. So 6 is going to g, so 4 times 6 is 24. 24 take away 3 is 21, so that's 21 over 3. So now I want the f of 21 over 3. So what is 10 take away 3 times by 21 over 3? Well, that is just 10 take away 21, which is negative 11, but it's the modulus function, so that will simply be positive 11. Solve the fg of x equals x, so I'm going to put the function of g into f, so all of this stuff here will replace that x. So this is going to be the modulus of 10 take away 3 lots of 4x take away 3 all over 3, which is 10 minus 4x plus 3, which is 13 minus 4x. Okay, so this is the fg of x. Again, sorry, that should all be in a modulus sign there. So it's the modulus of 13 minus 4x equaling x. So first of all, I can simply write 13 take away 4x equals x. Add 4x to both sides, giving me 5x. So 5x is 13, so x is 13 over 5. And it's also minus 13 take away 4x equals x, or 13 take 4x equals negative x. So that's minus 13 plus 4x equals x. I'm going to take away an x from both sides and add 13 to both sides. So x is 13 over 3. So two solutions, 13 over 5 and 13 over 3. Okay, here we've got the f of x is 1 over x plus 3, and we want to find an expression for the f squared x. Seems like something quite confusing, but f squared is just f. So all we're doing is putting f into itself. So in f, whenever we have the letter x, we're replacing it with a whole function. So instead of 1 over x plus 3, it's going to be 1 over x plus 3 plus 3. Okay, so let's tidy this up a little bit. So on the bottom, it's going to be 1 on the top. We're going to have 1 plus 3 lots of 3x plus 3. So that's 3x plus 9 over x plus 3. and that is 1 over 3x plus 10 over x plus 3, and that can be written as x plus 3 over 3x plus 10. If you're not confident with knowing that you can just jump that up there, what we've got here is 1 divided by 3x plus 10 over x plus 3, which is the same as 1 multiplied by x plus 3 over 3x plus 10, which was what I had over there. So again, with a bit of experience, these things become fairly second nature. Okay, so what we've got here is this is f squared x, and we want f cubed x, which is the f of x. So I've already worked out the ff of x, so I need to put the ff of x into the function f again. Okay, so I might run out a bit of space here, so I'm going to replace the x of 1 over x plus 3 with a whole of x plus 3 over 3x plus 10, and then plus that 3 again, which is 3 over 1. Again, I'm going to cross multiply, so that's 1 over x plus 3 plus 3, lots of 3x plus 10, so that is 9x plus 30 all over 3x plus 10, and that is therefore going to be 1 over 10x plus 33 over 3x plus 10, which can therefore be written, sorry, it's a bit squashed there, isn't it, as 3x plus 10 over 10x plus 33. There we go. So always handy to remember that when you've got a fraction, when the denominator is also a fraction, then the denominator of the fraction on the bottom, you can just simply move up to the overall numerator. Okay, so this is a tricky one because it's got logs, and logs are always a bit of a pain in the backside. So first of all, the fg of x, g goes into f, so that's simply going to be 3 to the power of, instead of x, x plus 3, and for the gf of x, I'm putting f into g, so x will be replaced with 3 to the power of x plus 3. So what I want to solve is 3 to the power of x plus 3 equals 3 to the power of x plus 3. Okay, so what I can do is, I mean, like, if you're a student, I do have a bit of sympathy for you here. You're just going to be hacking around probably, hoping for the best until maybe you get something that looks vaguely like an answer. Now, 3 to the power of x plus 3, that can be split up into 3 to the power of x multiplied by 3 to the power of 3. And so that equals 3 to the x plus 3. I'm going to get the other 3 to the x onto the other side as well. So I've got 3 to the x multiplied by 3 cubed, take away 3 to the x equals 3. Now, I've got a 3 to the power of x in this first part, and of course I've got a 3 to the x there, therefore I can factorise it out. So that's going to be 3 to the power of x multiplied by 3 cubed, take away 1, and that equals 3. 3 cubed is 9 times 3, 27, take away 1 is 26. So that is 3 to the power of x multiplied by 26 equals 3. So therefore 3 to the power of x is 3 over 26. Okay, so what it wants me to do, I mean, I could actually solve it here, but it wants it in the form of ln A over ln B. So I think I've only modelled it like this because there's a question like this in the book. So the ln of 3 to the power of x must equal the ln of 3 over 26. So with log laws, this power can come down to the front. So therefore x is the ln of 3 over 26 all over ln 3. And we are done. So pretty nasty, that one. Yeah, it's the introduction of all the logs that makes things a bit ugly there. Okay, so here's one final question on this topic of composite functions. We want the gf of x. So we're putting f into g. So instead of it being e to the 3x, it's going to be e to the 3 ln x plus 5, take away 3. Now what we really want to achieve is to get e and ln next to each other so they can cancel each other out. And we can do that by the number before the ln, that can be made the power of the x plus 5. So this is the same as e to the power of ln x plus 5 cubed minus 3. And now e and ln are together and they will cancel out. So the function is simply x plus 5 cubed minus 3. You see a lot of questions where you get e's and lunds together, and the idea is that you can work them so they can just cancel each other out. So that's the gf of x. So we want the gf of 10, so therefore the gf of 10 is going to be 10 plus 5, or 15 cubed take away 3, and 15 cubed take away 3 is 997. And for the third part, the gf of x is 150, so what we want is x plus 5 cubed minus 3 equals 150. So once we've done the first part, parts 2 and 3 are pretty straightforward, so I'm just going to add 3. So x plus 5 cubed is going to be 153, so x plus 5 is the cube root of 153. So x plus 5 is, right, let's just check that out. The cube root of 153, so 5.348. So therefore x is going to be 5 subtracted from that, so 0.348. That's just giving me answers to 3 decimal places there. So not too bad once you've worked out that nasty gf of x.